So thank you, Robert, for the introduction, and good morning, everybody. It's really a pleasure to be here with you today. So we have a very beautiful forest behind us. Remember last time you walked through a forest? You probably heard some insects or probably saw some birds or squirrels. Now, I have a question. What about all these tiny little creatures that you couldn't see or hear? They're very important, but they are also in danger. So today, I want to show you how robots can help us to uncover this hidden life before it's too late. So this is a very urgent problem. Life is disappearing at an unprecedented rate. Over 1 million species are facing extinction in the next 20 years. And these creatures that are often completely invisible to us, they sustain the very system we depend on. You can think about food production, provision of clean water and air. They make our planet alive, and they make our economies possible. So we need to do something. But unfortunately, our effort to restore and preserve biodiversity, they often fall very short. And the reason is that biodiversity is complex. And it's complex to measure biodiversity. So it's complex to set thresholds and to monitor progress. Because measuring biodiversity is about surveying hundreds, if not thousands, of different species in many different ecosystems. So current survey methods are simply not scalable, spatially, temporally, and taxonomically. They are very species-specific, they are very labor-intensive, they are invasive, and it's hard to deploy them in hard-to-reach environment. So with my team, we are overcoming this limitation by combining something that is familiar to all of us, robots, with something that we cannot see, environmental DNA. Now, every animal or organism shed a trail of genetic traces behind. This is the so-called environmental DNA. And these traces are everywhere, in the water, in the air that we are all breathing right now, and even on surfaces. So just by swabbing a leaf, we can collect these traces, analyze them, and associate them to the species they come from. Now, this is a game-changing for many reasons. So first of all, with a single survey technique, we can detect organisms from all domains of life. So we have a very broad taxonomic coverage. It's non-invasive, and also is highly sensitive, meaning that we can detect also these very elusive species that will constantly escape our nets or our camera traps or our eyes. And what we're doing, we're making a very important step forward by using drones to automate the collection of eDNA. So we can make this survey scalable, we can make it fast, cost-effective, and also possible in environments that are very hard to reach, like forest, and especially tree canopies, which are a hotspot for biodiversity, so it needs to be surveyed. So the e-drone is the first drone that can collect eDNA by landing on branches. So we have this force sensing cage that measures the interaction force and use this information to stabilize the landing with branches that are very dynamic and unpredictable substrates. On the outer cage, we have a sticky material that collects DNA and DNA-containing particles, peeling off these particles from the bark and the leaves of our plants. And what you can see there is actually a picture of the 21 taxa that were hiding in the forest nearby our lab. So the drone was, for us, a very important proof of concept. But clearly, we can't have an impact on the biodiversity crisis just by serving our backyard. So luckily, we had the opportunity to prove our solution in one of the most iconic as well as challenging environments on Earth. These are the rainforests. So they are home to 50% of all terrestrial plant and animal species, but they are disappearing at an unprecedented rate. So it's very important that we monitor as fast as possible. This is why the X Prize Foundation launched a competition to really accelerate the development of technology to survey biodiversity in 100 hectares of rainforest in just 24 hours, to provide a very accurate picture of life. And this is not just what we can see from above, because there is an entire world beneath the canopy. And even our best satellite cannot access this world. So how can we do that? Well, we can use probes, robotics probes, lowered from drones, to access this world. These probes can penetrate 40, 50 meters inside the canopy. They cross all layers from the very top up to the forest floor. And by interacting with vegetation, they can swab and collect environmental DNA. So using drones to collect eDNA, but also using drones to deploy sensing platform equipped with cameras and microphones on the treetop, we were able to build a very comprehensive multimodal biodiversity monitoring system capable to capture life with extraordinary detail. So we were able to make over 500 detections in just 24 hours. Making us one of the winning team out of the more than 300 that entered into this competition. But what is more extraordinary is that more than 100 of these genetic traces were completely new to us. And who knows, this might be our next Velcro or might be our next life-saving drug, because many drugs come from compounds found in nature, some of them in rainforests. So this is why now, with the prize that we won, we are continuing to collaborate with local indigenous communities so that we can use our technology to support their restoration efforts, so that we can protect this incredible richness, but also they can benefit from their environment. Now, as a last slide, I want to come back to Switzerland, because over the past 2 years, we started to translate everything we learned to tackle a very important local challenge. This is invasive pests, like, for example, the Japanese beetle, which is causing huge damages to crop in Ticino. This is not an isolated problem. Actually, today in Switzerland, every year, pests cause more than 150 million damages in Swiss francs. And this number will increase if we don't do something, mostly because due to global warming, many more habitats are becoming favorable for these and other species. Now, current visual survey method, of course, fails to detect invasive pests at early stage when eradication is more effective. Imagine how difficult it is to spot 1 or 2 insects in an entire vineyard. But with our drones, what we can do, we can systematically survey very large areas, and especially we can detect the many genetic traces that even a single individual insects shed in the environment. And in fact, our preliminary work shows that we are able to reveal pupilla presence 4 weeks before it is visible. And I believe that these 4 weeks can and must make the difference and help us to contain this outbreak before they make huge damages to our economies and to the crop. So to conclude, in this presentation, I show you how our robots are helping us to reveal and to map life with an unprecedented resolution. But remember that only we can decide how to translate this data into actions. So we have the technology, we have the knowledge, so sustaining our natural world is something that we must do quickly. Thank you very much.
Hey. Thank you, Stefano. This was amazing. I really love how you go into these environments and find ways of interacting with a world that we usually don't have robots go into. Yeah. They get stuck.
Challenging.
Exactly. And so there were several questions coming in. And let me pick one of the more sort of like repeated thematic questions. So when you actually go in and probe, for example, in the rainforest, how much of it is an autonomous decision-making of where you go versus how much you have to pick and still sort of, as a human, curate the process?
Decide what to do.
Yeah.
Yeah. So in the rainforest, we mostly sample over transect, so uniformly. I think that one of the problem, especially with eDNA, is that the distribution of eDNA is still quite unknown, and that's one of the challenge why we're using robots to acquire more data. And so once we have this information, I think we will be able to have more sort of autonomous and also adaptive system to automate the sampling based, for example, on different environmental parameters that we can measure. So that's a work in progress.
Okay. And how do you avoid bias on a bigger scale? Because you're obviously here focusing with drones, particular form factors of drones, and there's this question,
yes.
What about specific areas where plants are? Like in water, on other parts of the earth, not up in the canopy, for example. So how do you avoid a bias that you give too much focus on one thing?
Yeah, that's a very important question. Actually, what we developed for the rainforest is really a multimodal system, collecting different data, but also really collecting from different layers of the canopy, from the very top to the very bottom, also collecting water samples. So we try to be really comprehensive in minimizing this bias by accessing many environments and by collecting different type of data, eDNA, images, audio as well.
Great. And with this, also in the interest of time, thanks a lot, Stefano.
Thank you very much.
Let's give a hand again for Stefano.
Thank you.